Okay, everybody. In this section of PS154, I want to introduce you to LaTeX. Our objective in this part of the course is to learn to create LaTeX documents and to use LaTeX notation. So perhaps the first question is, what is LaTeX? First of all, it's pronounced LaTeX as opposed to LaTeX. It is a highly controllable and free typesetting utility program. You'll all be familiar with Microsoft Word, and Microsoft Word allows you to see the format of the document that you're creating as you create the document. And so Microsoft Word is known as, or can be described by the acronym, what you see is what you get, or WYSIWYG. LaTeX, on the other hand, is a utility that creates a document by virtue of coding. So what you get is what you code, as opposed to what you see is what you get. So those two acronyms describe the, I suppose, fundamental difference between Microsoft Word and a typesetting utility program like LaTeX. This is an interface that you will see when you create your first document. In Microsoft Word, let's say you would create a document pretty much like what you see there, and it would be in the form that you expect it to appear as you type. However, with LaTeX, you enter code that describes how the page will appear when you've completed your document. And so the coding that you enter in this section of the screen results in a particular format of text and images and so on, formulae on the right-hand side of the screen. So every time you change something on the left, it recompile, and that recompilation becomes evident on the right-hand side of the screen. So this is where we get the notion that what you see is what you code. You code it on the left-hand side, and you see it on the right-hand side after you recompile. There are online and installed versions of LaTeX available, usually free. We'll be using Overleaf, which is a free online utility, so you won't install it on your computer. Rather, you create an account on Overleaf online, and you perform all your activities through the online interface. Again, this is an example of the online interface. We will also use LaTeX notation in loop. So loop is configured so that if you want to enter a formula, you can do so. You can render a mathematical or scientific formula correctly in loop because it understands LaTeX notation. So we'll come to that as we go on. Also want to show you the typical LaTeX logo that you'll see as you go ahead. So we might ask the question, well, why use LaTeX? It is often used by science, computing, and maths professionals to create documents that need to render scientific notation and formulae. I suppose Microsoft Word doesn't necessarily, or other common applications cannot always render a formula in the desired format. Some academic journals will require papers or articles to be submitted in text format. So if you are publishing a research paper, you might actually be told beforehand you have to submit it in text format. And some physics students in recent years have been using this utility to create or format their final year project document. So the learning outcomes for this section of the course are to be introduced to LaTeX as a means of creating documents or papers, to create a simple LaTeX document with text, images, and formulae, and to understand the somewhat cryptic style of the page coding or typesetting notation. You're going to learn to enter and debug LaTeX instructions or directives. You will also learn to enter LaTeX notation in loop. So as part of the exercises for this section of the course, you will create a simple LaTeX document can save that document on the online utility, and then you will upload a PDF version of the document or download a PDF version of the document to your own computer. You will then create and edit a more complex document with images and formulae, and you will change aspects of that document um, as you work with it. And then save that document in a PDF format. Subsequently, you will see that LaTeX notation can be used in loop. And so we will then do a post-class loop quiz to affirm the learning that you will have achieved and the exercises that you will do. Okay, so you will do a preparatory exercise, which will involve accessing some tutorials online. There will be some videos and some text instructions that you can access to get a good introduction to how you use Overleaf online to create LaTeX documents. After that, I will ask you to create a simple one-page LaTeX document. It will just affirm that you're able to log in and do something very simple with Overleaf, and then save that as a PDF. Second exercise will involve me giving you some text, which is a very well formatted LaTeX document, and I will ask you to make some amendments to that document, make some changes to the document, save it as a PDF, download it, and submit it on Loop. I suppose the difficulty in that exercise will be entering code to change aspects of the page, debug the mistakes that we all inevitably make in entering cryptic code like LaTeX code is, and finally get the document correct in the format that you want it to be. Finally, to affirm the learning in the other two exercises, there will be a multiple choice quiz, which will enable you to answer some questions that you will have prepared yourself for in the previous exercises. It will also enable you to enter some LaTeX code inside Loop. And as I mentioned before, Loop is capable of rendering a formula correctly using LaTeX notation. So I will produce and publish on Loop detailed instructions for all of the exercises that you need to do. Free resources that are available on Overleaf include Learn LaTeX in 30 minutes, a tutorial, and there are 7 videos at the link I'm pointing at now, but all of this will be published on Loop. So enjoy creating 1 or 2 LaTeX documents, and hopefully you'll get some benefit for it.